Hi there, boys and girls, and welcome back to Conquering Math, where it all adds up. Today we will be learning about prime factorizations. Let's dive on in. By the end of today's lesson, you will be able to use prime numbers and factor pairs to find the prime factorization of a number. The Common Core State Standard today is 6NS4. We need to start by discussing factor pairs and prime numbers. A factor pair are two factors that multiply to produce a specific number. For example, 3 and 6 multiply to 18, so 3 and 6 are a factor pair of 18. Now let's talk about a prime number. A prime number is any number with only one factor pair, 1 and itself. For example, 13 is a prime number because the only factor pair of 13 is 1 and 13. Example number 1. Find all of the factor pairs of the number 28. There are two options to display this information, but both use the same method. So for now, we'll practice both options and you can choose the one that you like best. So for option number 1, we need to start with the factor pairs. The easiest factor pair is always 1 times the number itself. So in this case, the first factor pair is 1 times 28. Next, we try the number 2. 2 is a factor of 28, so we need to find the number that is paired with it, which in this case is 14. So the next factor pair is 2 times 14. Now we'll try 3. 3 is not a factor of 28, so we don't write it down. Now 4. 4 is a factor of 28, so our next factor pair is 4 times 7. Now we try the number 5. 5 is not a factor pair of 28, so we don't write it down. Then 6, which is also not a factor, and then 7. 7 is a factor of 28, but it's already written down, so we know that we're done. Now we'll take a look at option number 2, which uses the same method, but is just written slightly differently. Start by writing the number up on top, in this case 28, and start with the first factor pair, 1 times 28. Then move on to 2, 2 times 14, move on to 3, which doesn't work, so we don't write it down, and then 4, so we have 4 times 7. Then we try 5, but we know it doesn't work. 6, we know that that doesn't work, and then we're back to 7. And once you wrap back around, you know that you're done. Example number 2. Determine whether each number is prime. For each number, we will write down its factor pairs, and we'll know it's prime if it has exactly one set of factor pairs, 1 and itself. If it has 2 or more factor pairs, we will know that that number is not prime. We'll start with 15. We need to write down the first factor pair, 1 times 15, and then we'll check number 2, which is not a factor of 15. 3 is a factor of 15, so we have the factor pair 3 times 5. 4 is not a factor of 15. 5 is, but we already wrote it down, so we know we're done. So 15 is not a prime number because it has 2 factor pairs. Now let's try part B, the number 7. Start by writing down the first factor pair, 1 times 7, and then we'll try the number 2, which is not a factor of 7. 3 is not a factor of 7. 4 is not a factor of 7. 5 is not a factor of 7. And 6 is not a factor of 7. That brings us back to 7, so we know we're done. 7 is a prime number because it has one factor pair, 1 and itself. Now finally, let's look at part C, the number 13. We write down the first factor pair, 1 times 13. Now we check each individual number between 1 and 13, and between 2 and 12, there are no factors of 13. This means that 13 is a prime number because it has one factor pair, 1 and itself. Now we are ready to talk about prime factorizations and factor trees. The prime factorization of a number is that number expressed as the product of only prime factors. It's important to note that each number has its own unique prime factorization. Here are two examples. The prime factorization of 15 is 3 times 5. The prime factorization of 24 is 2 times 2 times 2 times 3. A factor tree is a tool to help identify the prime factorization of a number. Only prime numbers will be found at the ends of each of the branches. Let's look at the example for 18. We start by breaking 18 down into the factor pair 2 times 9. 2 is a prime factor, so we circle it, but 9 isn't, so we have to break it down again into its factor pair of 3 times 3. 3 is a prime number, so we circle each of the 3's. Now we know that the prime factorization of 18 is 2 times 3 times 3. Example number 3. Create a factor tree for the number 16. Step 1. Place the product at the top of the factor tree. Step 2. Write a factor pair underneath the product. Connect with branches. You'll notice that I chose the factor pair 4 times 4, but you can choose any factor pair of the number to make this work. Step 3. Circle prime factors if any. 4 is not a prime number, so you'll notice that I didn't circle it. Step 4. Repeat this process until all branches end with a prime factor. The factor pair for 4 is 2 times 2, and since I have two 4's, I have 2 sets of this factor pair. 2 is a prime number, so I circled it, and now all of the branches end with a prime number, so we're done. Example number 4. Use a factor tree to find the prime factorization of the number 28. Step 1. Create a factor tree for 28. This time I started with the factor pair 2 times 14, and 2 is prime, so I circled it. Then I broke 14 into 2 times 7. 2 is still prime, and 7 is also prime, so I circled each of those. Step 2. Write 28 as a multiple of its prime factors. So we have 28 equals 2 times 2 times 7, or 28 equals 2 squared times 7. This is the prime factorization of 28. Example number 5. You are organizing the cupcake table for the spring party. There are 18 cupcakes. How many different rectangular arrangements can you make? If we find the factor pairs of 18, these will represent the different number of rows and columns that we can make with the cupcakes. So we start by finding the factor pairs. We have 1 times 18, 2 times 9, and 3 times 6. This means we could have 1 row of 18 cupcakes, or 18 rows of 1 cupcake. We could have 2 rows of 9 cupcakes, or 9 rows of 2 cupcakes. And we can have 3 rows of 6 cupcakes, or 6 rows of 3 cupcakes. So there are 6 possible arrangements for the cupcakes. 1 row by 18 columns, 18 by 1, 2 by 9, 9 by 2, 3 by 6, and 6 by 3. Today you learned how to use prime numbers and factor pairs to find the prime factorization of a number. The Common Core State Standard today is 6NS4. Now that you are familiar with these techniques, complete the independent practice problems in your guided notes packet. Then watch the independent practice solutions video to check your work. Thanks for watching this episode of Conquering Math, where it all adds up. I'll see you next time.